Section 6.6, the remainder and factor theorem. Synthetic division can be used to find the value of a function. So our root in this polynomial is 3. So we're going to set it up in synthetic division. So the 3 goes in the half box. We don't have any missing terms, so we're going to make our column headings. Bring down the 3, bring down the negative 3, and then do the multiplication for the synthetic division. The remainder is negative 8. Okay, now watch what happens if we're going to do this a different method. This is going to be using direct substitution. So we put the root, which is 3, in for x. So everywhere we see x, we're going to plug in 3. And we get negative 8. So it's the same answer that we got when we did the synthetic division. Our remainder was the exact same answer as this answer when we plug in 3. So there's two methods to find out what your y is or your f of x is. You can do what's called the synthetic substitution or the direct substitution. So let's do this example. So we're going to do two methods. The first method is using synthetic division, which we call synthetic substitution. And whatever our remainder is, that is our answer. So notice that it's f of 4, so that is our root, 4. We do have a missing term. We have a missing x squared, so we're going to have to fill in with a 0x squared. Do the synthetic division. And we get 662. Now, if we use the direct substitution, we're going to plug that in, and we will also get 662. So there's two methods to finding the answer, using synthetic substitution or direct substitution. Which one will you do? You'll do whatever the directions tell you to do. Notice that the value of f of x is the same as the remainder when the polynomials is divided by the x of x minus 3. This is called the remainder theorem. So when you do the synthetic substitution, it's called the remainder theorem because the remainder is our answer. So let's use the synthetic substitution method, which is using synthetic division to find the answer. So our root is 3. So my remainder is 19. Therefore, that means f of 3 is 19. So if I were to plug in 3 into the equation, everywhere I see x, I would get 19. Okay, let's look at this polynomial. It is an x plus 3. The root is negative 3. So let's plug that in and see if we get a 0 remainder. So we're going to plug it into the polynomial. When we do, we get a 0 remainder. When you get a 0 remainder, what that means is that x plus 3 is a factor of that polynomial. To find the remaining factors, you will need to factor the remaining polynomial. So we're going to put in our variables. So remember, when you put in your variables, you knock it down a degree. The problem started with x to the cube, so we're going to replace it with x squared. So that's 2x squared minus 9x plus 10. We're going to factor into two binomials. Notice the last sign is positive, so that means the signs are both going to be the same. They're both going to be negative. We don't have any choice to use factors of 2 as 1 and 2, so 1x and 2x. With 10, we can either use 1 and 10 or 2 and 5. I'm going to try the 2 and the 5. And when I check, I get my outside term is a negative 5x. My inside term is a negative 4x, which is negative 9x, my middle term. So that factors. Sorry. This is called the factor theorem. If x minus r is a factor of the polynomial, if and only if the remainder is 0. So you've got to make sure if you have a 0 remainder, then whatever you divided it by is a factor. Example 3a. Determine whether x minus 5 is a factor of x cubed minus x squared, 7x squared plus 7x plus 15. Then find the remaining factors. So we are going to use the synthetic division. So my root is 5. I put in my column headings. I don't have any missing terms. I got a 0 remainder. So that means that x minus 5 is a factor. To find the remaining polynomials, I am going to plug my variable back into the remaining numbers. So that's x squared minus 2x minus 3. And then I'm going to try to factor that trinomial out. And it factors. So I'm going to bring that x minus 5 down. And these three factors are factors of that polynomial. Now, if I asked you for the answers or the x-intercepts or the roots, then I would put each of these factors to 0 and solve. But the question is just find the remaining factors, and those are the factors. Let's do example 3a. Determine whether x minus 2 is a factor. So my root is 2. I'm going to write my column headings. I don't have any missing terms. Do the synthetic division. Once again, I got a 0 remainder, so that means x minus 2 is a factor. To find the remaining factors, I'm going to put in my variables into the remaining numbers. So it's x squared minus 5x minus 6. And then I'm going to factor that trinomial into two binomials. My signs are going to be different. Factors of 6, subtract to get 5, 6 and 1. And then I'm going to bring that x minus 2. These three factors are my remaining factors. And I knew I was going to have three factors because look at your highest exponent in the problem. The highest exponent is x cubed, so that means you're going to have three answers, or in this case, we're just finding the factors, three factors. Okay, you try to do example 3b. Let's see how you did. Okay, here's your homework assignment.